Dr. Balakrishnan Manikam completed his doctoral degree in physics from IIT Chennai. He joined Indian Space Research Organisation in 1984. He coordinated the setting up of NNRMS, National Natural Resource Management System in the country, which helped to promote the use of satellite observations in assessment natural resources, disaster mitigation and environment protection. Dr. Balakrishnan coordinated several national projects and helped in setting up of advanced laboratories for satellite data analysis in the country. He also played a key role in developing several indigenous weather instruments such as automatic weather station, GPS sound and LiDAR and establishing networks across the country. He worked as an expert in remote sensing at the United Nations program Bangkok for over 15 months. He has traveled widely and helped as consultant in several countries to set up facilities and training in satellite applications. He has about 25 years of experience in teaching in the areas of physics, mathematics, space science, atmospheric science and applications of remote sensing and GIS. Dr. Manikam has over 200 published papers in peer-reviewed national and international journals. Currently, he is a visiting professor in Bangalore University.
Welcome to the UGC series of lectures on environmental sciences. Today, we talk about new paradigm in disaster management. As you are all aware, disasters cause major damage in the country and lead to a lot of losses. In today's lecture, we will cover definition of disasters and types, natural disasters affecting our country, technology of satellites and its applications, then various disaster management techniques and a scientific disaster management system. Our country is one of the regions which is affected by many natural disasters like cyclones, floods, droughts, earthquakes, landslide, etc. Different parts of the country is affected. This is basically due to the fact that India is covered by plain land, mountainous region, very high mountains like the Himalayas and then the large coastline. You can see here the affected areas due to cyclones which occur in the Bay of Bengal and sometimes in Arabian Sea and affecting our east and coastal region. Now, when we talk about floods, we have got a large river system. Many large major rivers are there in the northern region and in the southern part of the country. And during the monsoon season, they get affected, leading to very large floods. And these are the areas which are getting affected by the floods. Especially the northern region is maximum affected, and in particular Assam. We also have earthquake as one of the disasters, because Indian peninsular region is still emerging from the ocean and it is affected on one side by the large mountainous region of the Himalayas. Because of this compression of the plates, earthquakes occur and there is a very large area potential for earthquakes. And in the central region of the country, a few areas are there. Basically, the zone 5 and zone 4 indicated by these colors, they are actually most potential for earthquakes. And when we come to another disaster, that is droughts, you can see here the yellow color indicates Karnataka, parts of Karnataka, Andhra Pradesh, Maharashtra, they are all, and Gujarat, Uttarakhand, they are all affected by droughts. 2 droughts occur once in 5 years. That is the frequency of the drought occurrence. Now, what is a program in our country for responding to these natural disasters which occur on and off and suddenly. The natural disasters basically are very sudden in nature and affect large area and thereby large population. Considering this fact, the Government of India, the Union Cabinet with the Prime Minister as the chairman, is the highest body that oversees the disaster. And there is a disaster crisis management committee on one side and the agriculture minister, because agriculture is one of the major sectors affected by disasters. Then Secretary Agriculture and relief commissioners are there for every state, a central relief commissioner, and the scientific departments like Indian Meteorological Department, Indian Space Research Organization, Central Water Commission, Central Groundwater Board, Geological Survey of India. All these departments provide the necessary scientific output. And there is a crisis management group working on 24/7 mode, which is continuously monitoring the country for any natural disasters and a quick response. Now, let us try to understand how the disaster occurs and what is the different components of the disaster management. A disaster, as you can see here, occurs suddenly and the immediate requirement is response. We need to respond to the disaster in terms of medicine, food and rescue. Then comes a stage of rehabilitation. A large number of people are affected by the disaster and they have to be rehabilitated. They would have lost their home, their property they would have lost, valuable things they would have lost, and they need to be put back to normalcy. And then comes the reconstruction. Just like you may remember the Bhuj earthquake in Gujarat in the 80s, it had a very high impact with a large number of deaths. And the immediate requirement was reconstruction of the whole area in such a way that if such a earthquake happens again, they are not affected to this extent. So, that required even changing of the house construction and providing different relief centers and all that. And once this relief, rescue and rehabilitation is done, the next step is developing the region so that that becomes disaster proof. You have to make that region in such a way that next time when a disaster occurs, the impact is much less. So, one is prevention. To give an example, a flood is occurring continuously in one particular region. We have to find out the reason for the water to flow there and provide alternate routes of flood routing, alternate routes of water movement, so that the water does not come over there again and create floods. Then mitigation, teaching the people how to overcome disaster impacts, and in the event of disaster what to do, to teach and train them. And thirdly, preparedness, that in the event of a disaster, the people themselves start taking several actions, thereby saving their property and saving their lives. Now, let us see the impact of various natural disasters. You can see the different impacts, different disasters like earthquake, epidemic, extreme temperatures like hot and cold waves, then flood, then landslide and cyclonic storm, and other type of minor disasters like forest fire, landslide and all that. We can see here the cyclone takes the highest toll, the maximum impact if the cyclone, followed by flood and of course, earthquake. We can see here the overall impact around the globe. What has been the impact? The number of people affected, it has been very, very large. A big earthquake like what happened in Kobe, Japan, or a tsunami. Let us now see the impact of natural disasters across the globe. You can see here over the years from 1950, 60, 70 to present, the impacts have increased. One of the reasons is the large development of infrastructure, the population increase, all these are contributing to more number of people getting affected by disasters and more damages and losses. And some of the major disasters like the earthquake in Kobe, Japan, then the tsunami in the Indian Ocean, these are all have affected, and the cost has been in billions of US dollars. Now, let us see the typically what are all the disasters. The major natural disasters are flood, cyclone, drought and earthquake. Then there is a set of minor natural disasters like the cold wave, the hot wave, thunderstorms, mudslides, all these things. These affect at local scale, at regional level, affecting a few villages or a few towns, and the damage is accordingly less. Then we have got the man-made disasters like large scale fires, epidemic, then deforestation, pollution, chemical pollution and of course, wars. Now, let us see what are the different methods in which you can manage these disasters. In any disaster, one of the very important thing is forecast of the disaster. If you are able to tell that there will be a disaster at so and so region, such and such time, the people can themselves escape from the disaster. They can move out from there till the disaster is over, then get back to their places. So, one of the very important key element is observation of the disaster. You have to continuously monitor. To take an example of a cyclone, if you take the example of a cyclone where you can see here what are the different disasters. So, we need to actually continuously monitor the disaster through satellites, through ground observations and other means, so that we are able to provide necessary information to the common public to avoid the effect of the disaster. Now, you can see here the information can come from different sources like different government departments, then ground instruments, aircraft and satellite, and these lead to development of different maps like the flood map, drought map, hazard zones, risk map. There is any area in the country is mapped for what type of disasters it can occur. Accordingly, you can prepare the plan for managing the disaster. Now, I come to a new technology which over the last 20 to 30 years has come up in our country, and we have become a leading user of the technology. There is a technology of satellites. Indian Space Research Organization, as you are aware, is the agency which launches the satellite with cameras and other instruments, and we are able to take very good images, satellite images of different parts of the world. Here you can see some of the pictures, and it gives very good details of the houses and the roads and the aerodrome and all facilities, etc. And this is a picture of part of Gujarat, where you can see the agricultural fields. So, what happens in the event of a rainfall deficiency, a drought condition, we can monitor all these farms, agricultural farms, and try to understand how much the drought has affected these regions. So, satellite provides a very good tool to continuously monitor the different disasters. So, in the next few slides, let us see some examples how the satellite application has come to the country and how it has matured for use as an operational tool. One of the very important satellite is the meteorological satellite METSAT, which provides round the clock observations in 3 bands: visible, thermal and visible and water vapor. What happens? Whatever is happening in the atmosphere, if a weather system is forming, immediately the satellite is able to pick up that and give us the signal, so that we are able to continuously monitor that. Now, the different observation tools for weather observations and disaster management observations are One is the meteorological tower. A number of towers have been set up in the country with 60 meters and 100 meters, and what they do, they are continuously measuring the various weather parameters like temperature, humidity, winds, pressure, cloud formations. All these things are continuously monitored. So, at any point of time, we can find out if there is any big major development. The second big tool is the satellite. The satellite provides from the space 24/7 observations, means continuous observations at every minute, every second. We keep getting the data and we are able to know at what point where a weather system is developing. Now, the country also has developed what is called as Doppler weather radar. These weather radars are able to see distances of up to even 1000 kilometer into the ocean, and if a cyclone is forming, it is developing this Doppler weather radar, which actually sends a signal, electromagnetic signal, and receives the signal back after reflection from the clouds. It is able to assess how much clouds are there, what is their thickness, how much water vapor is there, and whether the clouds can cause large scale rainfall, etc. So, the Doppler weather radar, there is a network of radars in the country. Presently, there are about 30 radars are there, and the country has plans to increase the radars to almost 100 radars covering the entire country. Now, another set of systems are the automatic weather stations. These are actually working based on the solar power, which does not require any electricity or battery and all that. It operates using the satellite, the solar power, and it is automated. It provides every 3 minutes data, 3 minutes observation of the weather parameters, and this data is sent through a antenna element to the satellite, meteorological satellite, and it observes all this data and communicates to the Indian Meteorological Department and ISRO, which then analyze this data. Presently, we have got about 1500 such automatic weather stations in the country. Now, another very advanced instrument is the LIDAR. LIDAR is basically similar to radar, but using the laser principle. Laser beam is sent across to the atmosphere, and it returns from the clouds, giving us a lot of information about the cloud formation, what type of clouds they are there, whether they are rain bearing or not, whether they can cause large scale rainfall, high intensity rainfall, etc. Then we have got another instrument, that is a GPS sonde. This GPS sonde is a balloon borne instrument. In the balloon, this instrument is attached and it moves in the atmosphere. As it goes up to almost 30 kilometers, it can give the temperature, humidity, wind, etc. So, it gives a 3-dimensional data of the weather information in the atmosphere, 3-dimensional data, and all this data is put into the computer, a computer processing system, which actually then processes all this data and gives us a sort of warning, a forecast, whether a large scale storm is forming, whether there is a drought coming in, whether there is a tropical storm is developing, or a thunderstorm is developing. All these indications we are able to get through the use of this satellite data. Now, you can see here a very typical picture of satellite picture of a cyclone. Basically, a cyclone will be of the size of 1000 kilometer or more. It is a large vortex, large rotating system, and these systems form in the ocean and slowly move towards the land. And when they cross the land, they give lot of heavy wind, even up to 200-250 kilometers per hour, and heavy rainfall of 50 to 100 centimeters per hour, very high rainfall, and then cause lot of damage over the land. So, it is very important that we continuously monitor these cyclones. So, that is done using our meteorological satellite, and presently we have also got a microwave instrument in one of our satellites called OceanSat, which gives the wind conditions. As you can see here, within the cyclone, how the wind is forming, what type of vortex is forming, how strong it is, and which are the areas where likely to be having heavy rain and heavy wind. All these things are indicated and leading to very successful forecast of cyclones in the recent times. We have been able to forecast which districts will be affected, which state will be affected, so that people can move to safer places, cyclone shelters, and save themselves from the disaster. Now, another major disaster that occurs especially during the monsoon season, the heavy rainfall season, is the floods. And here you can see a typical picture of a flood damage over Bihar due to the monsoon rainfall, and these different colors are indicating the flood in different dates. Different days how the flood was there and how the flood has receded. Generally, a flood takes about 10 days to recede and completely come back to normalcy. So, we are interested actually to know the flood dynamics, so that we can make barrages, canals, so that the water can be drained, and in the future we can save from having a major flood damage. So, for flood damage measurements, it is very important to have such satellite pictures indicating which are the areas which has been affected largely by the flood. Secondly, in India we do not have a insurance scheme for the major disasters, because there is no information about the major disasters so far, but with the availability of satellite, the availability of very good ground measurements instruments, now we are actually developing a vulnerability maps, that is for every state which are the disasters which are affecting the state, which districts are affected, which villages are affected, so that we are able to give this information to the insurance companies, and they are able to work out the policy amount and then protect these people from the damages. This is a case where the satellite has been used at the village level. This is one taluk in Assam called Dhemaji, and you can see here in the maroon village how many people have been affected, how many cattle has been affected, how much agriculture area has been affected. To this detail, the satellite is able to provide the information. How this is done is using the new technology called the geographical information system, where we put the information of census, we integrate the information of census with the satellite data. Once you do that, first we find out which are the areas affected by flood indicated by this blue area, then which villages are falling in that area, and what is the population of the villages in that area. By integrating all this information, we are able to come up with very good flood damage statistics, and this helps the government, the state government as well as central government, in provide necessary facilities, provide necessary support, and provide necessary rehabilitation measures. And on the left side you can see here the vulnerability map, that is in the district of in the Assam, which areas are affected once in 3 years, twice in 3 years, or every year. So, we are able to find out some very potential areas, highly frequently flooded areas, and areas which are not that flooded and which are not at all flooded. By knowing this, we can concentrate all our efforts for flood management to those areas which are affected frequently. Now, here you can see a high resolution picture obtained from the airborne synthetic aperture radar. It is also a remote sensing technique. Satellites are there are aircrafts which can fly over the flooded areas. So, this is one such flood, and one of the barrage you can see here in the picture, the barrage has been affected, it has been broken, and that is why the flood waters have gone into the villages. So, actually they repaired this barrage, they made it more stronger, with that they could avoid future floods. So, in any flood we require all this engineering data, engineering information, so that we can protect from the future flood damage. Now, here we talk about another major silent disaster, that is drought. It comes in a silent way, but affects large areas and large population. Basically, it affects the very agricultural system and killing all the plants and with very little production. And satellites have been able to give at the mandal level, mandal or taluk level, information about the vegetation, and this method is called the NDVI, that is Normalized Difference Vegetation Index. The satellite is capable of seeing the vegetation very clearly, whether they are drying or not, whether their health is okay, all these things information it is able to give, and by monitoring this state wise, actually for the whole country it is being done now by ISRO at the country level, at the state level, at the district level, and even at the village level. We are doing this monitoring. Now, the state governments are able to get very good information about the drought affected villages. So, they are able to rush water, they are able to rush other relief materials, and they are also able to assure of alternate jobs for those farmers who do not have any earning during that drought year. Now, coming to the coastal areas, we have got about 6,000 and odd kilometer of coastal areas in the country, and they are very vulnerable to any sea level change or any disasters like cyclones. So, India is using the satellite data on a regular basis to map the coastal areas. We are continuously mapping the coastal areas, and we find that some areas the water has gone into the coastal areas. They are gone into the coastal areas, affected the villages, and the villages have to shift from there to other areas. So, this is a continuous process. Coastline mapping is being done continuously using the satellite data, because now we have got satellites which can give up to 1 meter resolution or better than 1 meter resolution, and this data is being used for monitoring the coastline. And another aspect that is being done is the coral reefs. See, India is a rich country in that sense. We have got a very good coastal waters and very good islands are there, surrounding which coral reefs form. These are all some type of formations which actually live only in particular conditions of water. They are very sensitive to the water temperature, salinity, the flow of water, and all that. And these are also indication of the good condition of the ocean waters. If these coral reefs are affected in somehow, then that means that the ocean waters are affected, ocean waters having some problem. So, to monitor this, there is special program is there. Entire coastlines of the various islands are continuously monitored, and the coral reefs are mapped, and we are actually protecting these as protected areas, and with no human intervention they are protected using the satellite data. Now, another major disaster which affected India in recent times is the tsunami. One of the major tsunami that affected actually was initiated by an earthquake that happened in Indonesia. In Indonesia, a major earthquake happened about 15 kilometer below the ocean bed, raising the waters to very large level, and that travelled as a wave. The basic difference between a tsunami wave and a normal surface wave is the surface waves are due to the winds. Whenever there is winds over the ocean, waves are formed, and these waves are only 1 or 2 meters thick, whereas a tsunami wave is taking the whole water of the ocean along with that. So, in some places the ocean is 7 kilometer deep, even that whole water is moved. So, tsunami waves are very, very strong, and when they come to the land, what happen? They become very large storm surges, very large surges, and they go over the villages, they go over the coastal areas and destroy the houses and property and kill people also. This is what happened in the recent tsunami. So, you can see one of the effects of the tsunami in this picture, in this satellite picture. This is part of the island, Trinket Island in our Andaman Nicobar Islands, and you can see here before the disaster, before the tsunami, the island was intact, there was no problem, but after the tsunami it became broken, it got cut up, and several ecosystems were destroyed, several people were destroyed, animals and all that, and we can see the effect of the tsunami. So, basically the strong waves of the tsunami has affected. So, one of the important things in the case of tsunami is we should be able to forecast properly tsunami and warn the people, especially in the coastal areas and in the islands, so that they can escape. In the event of a tsunami, the best thing to do is go to a higher place, because tsunami is nothing but a large wave coming a few times, and within a short time, like half an hour, the waves will subside and there will be no further damage. So, if one escapes that initial waves, then you are saved. So, towards this, the government of India started a program. What has been done is a Indian Ocean Tsunami Warning Center has been set up in Hyderabad, and this center is receiving data from ocean data buoys. There is actually floating buoys are there over the ocean, entire Indian Ocean region, and these are measuring the ocean pressure. The ocean water pressure they are measuring. Whenever the pressure goes up a particular value due to a tsunami wave, they will send a warning, and this warning is received in the Hyderabad center, and then immediately they inform it to the cabinet and other higher government officials, and the warning is given in the TV, All India Radio, and like that, and the warning is communicated, and the tsunami warning is given to all the public, and they are able to save themselves from the tsunami effect. Now, let us see what are the things that is coming up in the country towards disaster management. Basically, a whole lot of systems are coming up in the form of satellites. Specific satellites are there with high resolution. We are able to see entire country at high resolution, and with that, any time something happens, we are able to come to know it. A big forest fire or a flood or a drought condition or a cyclone, nothing is missed. All these are continuously being monitored by the satellites in the sky. Another important thing is emergency communication, because what happens during a disaster, all the communications break down. Entire our mobile and other networks, landline, all this internet, all this will fail, but the satellite communication can still remain. So, using satellite phones which operate through the satellites, we are able to communicate with Delhi and other regions, and we can actually continue to have the disaster management. And we have also a set of aircrafts with laser terrain mapper and real time mapping systems, so that after the disaster has happened, we immediately take action, and all these are being done in Hyderabad under a decision support center, and the decision support center gets all the information and then informs to the concerned chief secretary, chief minister, prime minister, and all concerned people, and a new paradigm in disaster management has happened, and we are going to have a much better, robust and very reliable system coming up in the next few years. Now, I would like to summarize. Before going to summary, I would like to also mention the satellite based mapping leads to so many informations. Various information is available in real time, and all these are to be used by the different stakeholders, like the state government, central government, and the community and all that. Now, I would like to summarize by our today's lecture. Basically, we looked at what is a natural disaster and what are the different types of disasters, and in particular in India, what is the effect of the disasters and which are the areas which are affected by the disasters. Then we could see in a disaster management what are the different steps required to manage a natural disaster, and the role of satellites, how the satellites are able to provide real time data, real time information, so that you can forecast the disaster, you can warn the people, and also rescue and provide necessary relief to the people. And a new paradigm in disaster management is evolving in the country. Now, I would like to give a few questions which could be attempted by the students. What are the major natural disasters affecting India? The second question, What way satellite data can help managing natural disasters? Third question, what are different observation methods to forecast natural disasters? Thank you very much.